Alright, our pistons came in. So, we have Wiseco forged pistons here for this new motor, and we're going to take the pistons and the block to the machine shop tomorrow, but wanted to go over what you should do before you take your pistons there, and rather than just explaining what to do, I find it helpful if I know why I'm doing something. So I'm going to go over a little bit of piston science, engineering science with you. So first of all, in addition to some cool stickers and some warnings saying that you can get cancer in California from them, your pistons will come with a spec sheet like this. And this is very important. It gives you a couple of things. The main thing is it's going to tell you where on your piston skirt you want to take measurements from. And the reason this is important is pistons are not perfect cylinders. They're actually cones. They're smaller at the top than they are at the bottom. The reason for this, I'll pull one of these out. Pause and admire just how pretty they are for a minute. I love a new piston. This will be creating power someday. Okay, enough of that. Metal expands when it changes temperature. When it gets warm, it expands. A piston is hollow at the bottom and solid at the top. Therefore, the denser top section is going to expand more than the tips of the skirt will. So what we want in an ideal world is when the engine is completely up to operating temperature, the piston at that point is a perfect cylinder, perfectly sealed inside the cylinder walls, going up and down. So that means at room temperature, this is not a perfect cylinder. It's actually a cone. So if you measure from the top of your piston, you're going to end up in trouble. So there's a specific point and a certain distance down from the top of the piston that they want you to take your measurements from, and that's going to be listed on your spec sheet. So in this case, they want you to measure from the bottom of this ring ridge 1.3 inches, and that's where they want you to take your measurement from. Alright, some pistons will have a window in the skirt coating or no skirt coating. On the Wisecos, they do not have a window, and you simply have to subtract the thickness of the coating when you go to do your measurements, because the coating doesn't count for your piston to wall clearance. Alright, second thing you're going to want to do. Speaking of piston to wall clearance, so what is piston to wall clearance? Piston to wall clearance is, again, the piston expands, so we can't make this and the hole it goes into the exact same size, or it'll seize when it gets warm. How much it expands, that depends on what type of a motor you're building. One reason why it's not normally a good idea to throw boost on a bone stock engine and run with it is you're changing the combustion temperature, and you at some point will make the piston expand more than it was designed to, and it'll get stuck in the cylinder. A lot of times you can get away with a lot. Some motors you can't. The Miatas seem to be pretty forgiving. You can get away with quite a bit doing it the wrong way. But when we're designing a new motor, we design it for the final application. So this motor in particular is going to be making in the neighborhood of 250 horsepower on it, 14-15 pounds of boost. So we're going to set our piston to wall clearance accordingly. Sometimes the piston manufacturer will give recommendations for piston to wall. Your machinist will have an opinion, and you can search what other people have used in the past. The general rule of thumb is, obviously, if your piston to wall clearance is too small, you can seize. If it's too big, you can get blow-by and or excessive piston slap while it's running, and it'll make a bunch of noise and shorten the life of the motor. Another thing, not all forged pistons are made of the same material. Some expand more and or faster than others do, so you have to keep that in mind. And it just takes a little bit of research to figure out what pieces you're going to use. I like to run on the Wisecos, if we're doing a forged motor making moderate horsepower, 200 to 300 ballpark range, we're going to run about 3 thousandths piston to wall clearance. Anywhere from 2.5 to 3.5 is going to be acceptable. That's going to give you enough room that you're not going to seize it if you run it on a hot day and you put a lot of combustion chamber temperature into it. But it's light enough that it's not going to get any piston slap. If you're going to air big, but try and get it spot on. We'll go over gapping the rings and when we get to that point in the build. For now, just know that the ring gap follows the same rule of thumb. Depending on your application, the ring gap changes. It's not one size fits all. So what we're going to do before we take these parts to the machine shop is, it never hurts to double check. I'm going to measure all 4 of these pistons to make sure that they're all the same before it goes to the shop. If I find one that's way out of spec, I need to let the machinist know so we can tailor it to a specific hole in the block. So to measure the pistons, get yourself one of these. Calipers are not good enough. You're wanting to find to the nearest 1/1000th what the diameter of your piston is. Alright, so we're going to measure from the bottom ring landing 1.3 inches. See where that ends up on the piston skirt. And you can see that I made a tiny little witness mark. Yep, see that? Do that on both sides. And then we're going to take our micrometer and measure the piston skirt and see what we come up with. We're going to compare that to the manufacturer's. Okay. Lock that in place. See what we got. So we have 3.3 on the chart. Alright, so we have 3.305. Okay, and that makes sense. And their recommended bore size is 3.307. So they're recommending a 0.002 piston to wall clearance. And that's correct because this coating's about 1/2 thou thick. So that would give me a nominal of 0.003 piston to wall, which is exactly where we want to be. So that's good. So this piston is exactly per the spec sheet. We're going to measure all 4 and make sure that they all line up. And we'll measure them again before they go into the block because it doesn't hurt to measure twice. And then we'll be all set. So, okay, a couple of piston trivia. On OEM pistons, usually there's going to be a mark on the top of the piston designating which direction goes forward in the block. On an aftermarket piston, since it's an aftermarket and used for multiple things, that's not the case. So you have to look at the valve reliefs and make sure that you put it into the block the correct way and not backwards. A couple cool things. So pistons will have holes drilled into the side of the piston that go all the way through into the center. In the oil ring landing, some oil is gonna get into the oil ring, and that's its path back into the bottom of the engine as opposed to going up and getting burned. Often on an old crusty motor that's been burning a lot of oil, you take it apart, you'll find all those holes either weren't big enough in the first place or have been plugged up. Another way that they can fail. So these Wiseco's have nice big oil reliefs, so that's good. I like seeing that. Another nice thing that the Wiseco guys do, they have already weighed all of the pistons and they write the weight of the piston on the bottom. I'm going to double check that when we go to balance the bottom end, but it's just a comforting thing to see when you buy a product that it looks like someone has taken care of the manufacturing process and done it properly. So yeah, really like these Wiseco pistons. Yes, they're a touch more expensive than the Supertex or some of the other import brands, but totally worth it in my mind. Another thing, when you buy your pistons, because I've had this bite me before, just double check that the rings they're packaged with are the correct size rings. Otherwise you'll be annoyed when it comes time to put them into the block and you don't have the right parts. I've had them accidentally ship the wrong rings before. So 8400, that is for an 84mm piston, which is what we bought. we're all good to go here. So I am going to take all 4 pistons, the spec sheet that comes with them, and the block to the machine shop. I'm going to explain to him my application, tell him what I would like to see for a piston to wall clearance, and ask his opinion. He's built more motors than I have. It's always good to see what he thinks about it. In this case, this is a motor that we have built before a couple of times, so we've kind of got it into a science here, so I'll ask him for yet another one of the same motor. Should take a week or two to get that machining work done, and then we'll be ready to start assembling. See you guys next time.